All right, today's problem is remove nth node from list end. So linked list question. More specifically, it's a fast slow pointer problem. You could say it's a two-pointer problem, but really it's a specific kind of two-pointer problem. It's a fast slow pointer problem. Asked at Amazon. All right, well, it's on InterviewBit, so you can go over to InterviewBit, pause the video, try to solve the problem over there. When you're done, come back and we'll walk through it. All right, problem description, given a linked, well, wait a second. Okay, yeah, given a linked list, A, remove the bth node from the end of the list and return the head of the list. So that's our input, the pointer to the linked list, A, and an integer, B, the bth node from the end of the list. For example, given linked list 1, 2, 3, 4, 5, and B equals 2, and we want to remove the second node from the end of the list. So the way we count that is we would start with 5 as 1 and then back up to the 4. That's 2. That's the second node from the end of the list. So the list becomes 1, 2, 3, 5. No more 4. Note, if B is greater than the size of the list, remove the first node of the list. I've never seen that constraint on this problem. This is a really common problem, but I've never seen that. I don't know. I can't think of a reason to provide a number that's greater than the size of the list, but there it is. Note, try doing it using constant additional space. Okay. Yeah, that's not a problem. Problem constraints, the length of A, length of the linked list will be between 1 and 10 to the 6th, which is 1,000,000. Input format, we get a pointer to the head of the linked list, and the second input argument is the integer, B. Output format, return the head of the linked list after deleting the bth element from the end of the list. All right. So, yeah, here's an example. We can kind of demo how this works here. Let me get a pen. All right. So the way it works is we have a fast pointer and a slow pointer. Now they both start out at the beginning of the list. For the fast pointer, we advance it by this amount, B. Okay, so 2. So the fast pointer would advance to the 3. Okay, slow pointer is still here. After that, we advance them one at a time until the fast pointer goes past the end of the list, gets to the null pointer at the end of the list. And so in order to do that, we would need to advance it 1, 2, 3 more times. So fast would then be over here. And because slow is 2 places behind fast, then slow at that point is still going to be 2 places behind fast right here on the 4. So we removed the 4. Well, that's about it. Let's look at the algorithm. So we have a fast pointer, we have a slow pointer. We start out, as I said, by iterating the fast pointer B times, moving it forward B elements. Now, because of this thing where they can give us a B that's larger than the size of the list, we have to add that and make sure that we're not blowing past. We have to check fast against null to make sure that we're not blowing past the end of the list. Okay, so after we've done that, we check for fast equal null, which could happen, if B is greater than or equal to the size of the list, then fast is going to be null. What that means is we need to remove the first element from the list. So A, which is the pointer to the head of the list, A equals A dot next, which effectively removes the first element, and then we return the header. Now, if the fast pointer doesn't go past the end of the list, then what we need to do is, okay, and I can see that visually I misrepresented this here. Let's do it one more time. All right, slow and fast. So fast will advance to, fast is going to advance here, right? Slow is still going to be here. And let's see, for I equals 0, I is less than B, and fast is not equal to null. Yeah, okay, so we advance fast B places, which is 2. When we drop into this while loop on 24, we are moving the pointers forward one element at a time, as long as fast.next is not equal to null. So really, fast.next is going to equal null when fast gets here. Okay, and slow, which is still 2 places behind it, is going to be here. So that is we don't want to get slow all the way to 4. I mean, 4 is the element that we want to remove, but we can't remove it if we move the slow pointer to 4, because what we have to do is on line 29, slow dot next. I can take the fast off of here now. Whoops. Slow.next. So slow.next is 4, and we're going to change that to slow.next.next, which is 5. So the slow pointer, the next pointer for slow, is now going to point to 5, and 4 is gone, and then we return the header. Okay, let's try this out. Okay, what do we cover there? Linked lists, 2 pointers. Really, it's a special kind of 2 pointers. It's a fast slow pointer. If you found this helpful, then hit like, subscribe, and check out the playlist on screen to keep improving your interview skills. The video description and the pinned comment have links to additional resources, including a free LeetCode patterns cheat sheet. You can download that immediately, and we'll see you next time.